Hi students, today we will be doing a quick recap on the determination of oxidation number of a particular atom. Now for your information, oxidation number is a number in which scientists use to determine the number of electrons that an atom has. Now, every atoms in the periodic table, they will have their own oxidation number. And bear in mind that this oxidation number might change when your atom interact with other elements or when they form ions and molecules. So now we will do a very quick summary on how to determine oxidation number of atoms when they appear as a different state. Now the atoms that we're going to discuss today, I've picked a few atoms to discuss. We have sodium, right? Let's pick magnesium as well, chlorine, oxygen, and nitrogen. And let's see how their oxidation number will change. Now, when you have these atoms appear as elemental state, bear in mind that when you have atoms in elemental state, their oxidation number is always 0. For example, when you have sodium in elemental state, the formula is Na, and magnesium in elemental state, you have formula Mg. When chlorine is found in elemental state, the formula is Cl2. Oxygen in elemental state is O2, and nitrogen in elemental state is N2. Now for all these atoms, when they are found in elemental state, their oxidation number is all 0, right? But sometimes our atoms might interact. Sometimes our atoms, in order to achieve stable electron arrangement, it will either accept or donate electron, and when they do so, they will turn themselves into monoatomic ion. Now the word mono suggested that this type of ions only has one atoms inside. Now when you have atoms that exist as monoatomic ion, the oxidation number will always follow the charge. Alright, say for example, when I have sodium reacts and form ion, it will form Na+. And when my sodium exists as Na+, its oxidation number now becomes +1. Why is it +1? Because we are following the charge of +1. Now one more example, you have magnesium. Magnesium, when it forms ion, it becomes Mg2+. When my magnesium becomes an ion, its oxidation number now becomes +2. Right, now how about chlorine? So chlorine atom, right, will form chloride ion. So when it exists as ion, now the oxidation number becomes -1 because we are following the charge of -1. Next, if I have oxygen, alright, it will form an ion with formula O2-. So when your oxygen exists as ion, alright, now in this case, the oxidation number would be -2. Now how about nitrogen? Nitrogen, when it reacts, it becomes N3-, alright, it turns into this form. So when your nitrogen becomes an ion, the oxidation number now also change accordingly. It becomes -3. Alright. Okay, so now from this example, what you can see that even though we have atoms of the same origin, sodium, when it appears as elemental state, right, its oxidation number will be 0. But when my sodium donates electron and turn into sodium ion, its oxidation number now becomes +1. So this follows what I've mentioned just now. Every atom has its own oxidation number, but the number changes when they are at different state. Right, so we move on to another example. Sometimes our atoms might interact with other types of atoms and it forms polyatomic ion. Now the word poly suggested that this ion has more than one type of atoms inside. For example, you have NH4+. Right, this is an example of polyatomic ion because in this ion I have nitrogen atom and hydrogen atoms inside. We have more than one atoms. Now another example, we have NO3 minus. Nitrate ion is also a polyatomic ion because you have nitrogen and oxygen atoms inside. Now another one, Cr2O72 minus. Dichromate ion is also one of the very popular polyatomic ions. It's made out of chromium atoms as well as oxygen atoms. Right, so let's say if our atoms interact with other atoms of other elements and it forms polyatomic ion. Now how do we find the oxidation number of my atom? Now to do this, you have to solve using calculation. To find the oxidation number of a particular atom in a polyatomic ion, you have to solve through a simple calculation. And according to the rule stated, when you do the calculation, the first thing is you will sum up all the oxidation number for every single atom. And you will equal it to the charge of that particular polyatomic ion. And bear in mind, during the summation, oxidation number of these three elements are fixed. Fluorine is always at -1, hydrogen is always at +1, and oxygen is always at -2. Alright, so with that, let's go into specific example. Now say for example, I have nitrogen atoms over here. It interacts with hydrogen and it forms a polyatomic ion with formula NH4+. Now in this case, what is the oxidation number of my nitrogen over here? Now to find this oxidation number, you have to solve calculation by first sum up all the oxidation number. Since I do not know what's the oxidation number of N and I need to find it out, I'll just put an X to represent. Next, I need to sum up all other oxidation numbers. So hydrogen, according to rule number 3, hydrogen has an oxidation number of +1. So it's 1. And in this polyatomic ion, I have 4 hydrogen inside. So now I sum up already. Next, I need to equals to the charge of ion. So you can see this ion has an overall charge of +1. So I let it equivalent to 1. Now I solve by X and I will get the figure of -3, which means to say in this polyatomic ion, the oxidation number of nitrogen is -3. Alright, now we go for one more example. NO3 minus. Now in this NO3 minus, so let's say in another situation, I have atom M. It reacts with oxygen and it forms a polyatomic ion, NO3 minus. So now in this case, the question might ask you, so in this polyatomic ion, what is the oxidation number of nitrogen? And to find this, you have to solve calculation. Following the step number 1, I will sum up all the oxidation number. So N has an unknown oxidation number, I just use it as X, plus oxidation number of oxygen, according to rule 3, is always -2, and I have 3 of them. Alright, and now you have sum up ready, you have to let it equals to the charge of the ion. So in this case, this ion has an overall charge of -1. So that means I'll put like this. Therefore, to solve my X is equivalent to +5. Which means to say the oxidation number of nitrogen in this polyatomic ion is +5. One last example. Now in this case, let's say if I have a chromium atom, reacts with oxygen and it forms a dichromate ion. Now then the question asks you, so how do I find the oxidation number of chromium in this polyatomic ion? So again, solve it using calculation. In this case, I need to add all the oxidation number. So chromium, I do not know the oxidation number, so I replace with X. And according to the formula, there's 2 chromium over here. So I have to modify by putting a 2X plus oxidation number of oxygen is always -2, and I have 7 of them. And the entire thing is equals to the charge of the ion. In this case, it's -2. Therefore, when I solve my calculation, my chromium will have oxidation number of +6. Alright, so this is how we figure out what is the oxidation number of a particular atoms when it is found as part of polyatomic ions. Next, we will look into a situation whereby our atoms reacts with other atoms of other elements and it forms a covalent compound. So let's say when it forms a covalent compound and to find the oxidation number of that particular atom, again, you have to solve through calculation. Alright, and the rule is pretty much similar like the one on top. So when you do your calculation, the first thing is you will sum up the oxidation number of all the atoms. But the difference would be now at point number 2, when you sum up the oxidation number for atoms in a covalent compound, you will let it equals to 0. So unlike the previous one, when you're working with polyatomic ion, when you sum up all the oxidation number, you will equal to the charge of the ion. But for covalent compound, you will let it equals to 0. And again, the oxidation number of fluorine, hydrogen, and oxygen is fixed at such figure. Alright, so with that, let's go to specific example. Say for example, if I have nitrogen atom, alright, it interacts with oxygen and it forms a covalent compound, nitrogen dioxide. So in this question, they might ask you, so in this case, what would be the oxidation number of nitrogen? So again, to do this, because this is a covalent compound, I will solve it using calculation by this method. So I will sum up all the oxidation number, and nitrogen is the oxidation number I do not know, and I need to add with the oxidation number of oxygen. Oxygen is always -2, and I have 2 of them. Now then I need to equals to 0. Now my X is equivalent to +4, which means to say in this covalent compound, the oxidation number of N is equivalent to +4. Right, next let's look at another example. Let's say if I have carbon dioxide. Alright, now so that means to say I have a carbon atom, reacts with oxygen atoms, and it forms a covalent compound CO2. Now, if a question asks you, what is the oxidation number of carbon in this covalent compound? So to solve this, follow the calculation, add on all the oxidation number, X. Alright, oxygen is always -2, and I have 2 of them. And I need to let it equals to 0. So X equals to +4. Alright, so that means to say in this case, the oxidation number of carbon is +4.